This is some optional practice for section 5.2, and specifically we're going to look at where two exponential functions are equal, or in other words, where they intersect. So if each one of these red lines represents an exponential function, what we're looking for where they're equal or where they intersect is this point here where the two functions cross, and then specifically we're looking for that x value that's associated with where those two functions are going to intersect. Right, so we have a couple of problems to try out. This first one is 5 times 1.15 to the x is equal to 8 times 1.07 to the x. So if we kind of think about this a little bit graphically, I have an intercept of 5 and an intercept of 8. This one that starts at 5 is growing faster. It's got a 15% growth, and this one only has a 7%. So this one will come through a little bit faster. This one will be a little slower, and so they will cross. Okay, and so let's go ahead and find where that's going to be at. I'm going to start by putting all the things that don't have x on one side and all the parts that do have x on the other side. So I'll divide this 8 over. I have 5 over 8 is equal to 1.07 to the x, and then I'll divide this 1.15 to the x also over to the other side. So I have all the pieces without x on one side and with x on the other. And then I'm going to use a property of exponents that's going to allow me to rewrite this as 1.07 over 1.15, all raised to the x. And the reason I want to do that is now that I have this x and the exponent for just one of these, I can now apply a logarithm to both sides and allow me to bring that x down in front. So you can use any log you want. I'll use natural log. So I have ln of 5/8 is equal to ln of 1.07 over 1.15 to the x. And then that law of logs allows me to bring the x down in front. So I have ln of 5/8 equals x times ln of 1.07 divided by 1.15. And then to solve for x, all I need to do is divide this piece to the other side. So I get ln of 5/8 over ln of 1.07 over 1.15. And that's going to be equal to x. So that would be the exact solution here. And then the approximate solution, we'll go ahead and put this into the calculator. Okay, so I have ln of 5 divided by 8 in parentheses, divided by ln of 1.07 divided by 1.15, also all in parentheses. So that gives me about 6.52. Okay, so that would be the approximate solution. All right, so we have another one here. So this one is a little more interesting. I have 1.7 times 2.1 to the 3x. It's a little more interesting exponent there. And that's going to be equal to 2 times 4.5 to the x. So I'll do the same thing. All the parts without x on one side, all the parts with x on the other. So I'll start by dividing this 2 over. So you get 1.7 divided by 2. And then I'm going to divide this 2.1 to the 3x over to the other side. So I'll have the 1.7 over 2 is equal to 4.5 to the x over 2.1 to the 3x. And then I am going to use that property of exponents to get that x out. So I have 1.7 over 2 is equal to 4.5 over 2.1 cubed. And that whole thing is raised to the x. So if I were going to undo this, I would distribute that x back out. So I get 4.5 to the x. And then that x would partner up with this 3. So I get 2.1 to the 3 times x, or the 3x. Okay. I have a single x up in the exponent. So now is a great time to use a logarithm to simplify this and to be able to bring that x down in front. So I'll use common log this time. So I have log of 1.7 over 2 equals log of 4.5 over 2.1 cubed to the x. And it doesn't matter whether using natural log, common log, any logarithm on these two. There's not a super advantage to using one or the other here, but both of them will work. And I'll bring that x down in front. So I have log of 1.7 over 2. Using the law of logs gives me x times the log of 4.5 over 2.1 cubed. And so I'll divide this back over to the other side. That gives me x is log of 1.7 over 2 divided by log of 4.5 over 2.1 cubed. We'll go ahead and put that in the calculator. So this is your exact answer here. What we get from the calculator will be our approximate answer. So I have, let's see, log of 1.7 divided by 2, all in parentheses, divided by log of 4.5 divided by 2.1 cubed, all in parentheses. So that gives me about 0.225. All right, so there's the first two. And then this one, both of the exponential functions are using e. So they have the same base. And so this will actually help us out a little bit and make it a little easier. But let's start by putting the pieces with x on the left and the pieces without x on the right. So I'll have e to the 0.081x. And I'll divide this e from the other side over. So I'll have that divided by e to the 0.032x is equal to 25. And I'll divide that 13 over to the other side. And then because I have the same base here, I can actually just subtract these exponents. So I have e to the 0.081x minus 0.032x is equal to 25 over 13. If I subtract this, I'll get e to the 0.049x is equal to 25 over 13. All right, so to solve this, I need to get that x out of the exponent, and I could use any logarithm I want, but this is a situation where using natural log is going to be more helpful. And that's because natural log and e are inverses. They're best friends. And so I'm going to use the natural log paired with the e. So I'll get natural log of e to the 0.049x equals natural log of 25 over 13. And then ln and e are inverses, which means this just simplifies to 0.049x. And that'll still be equal to ln of 25 over 13. And then to solve for x, I'll just divide by both sides by 0.049. So my exact answer is x is equal to ln of 25 over 13 divided by 0.049. The approximate answer will be what the calculator gives us. So I have ln of 25 divided by 13. It's all in parentheses, and then I'll divide that by 0.049. And so that gives me 13.345 approximately. Right, so there's a couple of examples of how to solve or find where two exponential functions are equal to each other or where they intersect.